Hello everyone. This video would focus on graphing absolute value equation in vertex form, and this is the second part. In this part, the absolute value of A is greater than 0 and less than 1. Before we go farther, please feel free to check out the description box below for the link of the other series of topics related to absolute value equation in vertex form. Before we go over this example right here, let's have a review on the basics of absolute value equation in vertex form. We remember that the equation for an absolute value equation in graphing form or vertex form is y equals a absolute value of x minus h plus k. Now let's go over the effects of the parameters a, h, and k to the graph of an absolute value equation. We remember that if A is positive, the graph opens upward. Now, if A becomes 0, then the graph becomes a straight horizontal line. On the other hand, if the value of A is negative, the graph of an absolute value graph will open downward. Now, we also remember that this A is called the stretch factor, meaning it makes the graph vertically stretch, which makes it narrower, or it makes the graph horizontally compressed, which makes it wider. We remember that the closer the value of A is to 0, then the graph becomes wider. So if you notice, the graph gets wider. We started from the negative side, and then we go towards the 0. It becomes wider and wider to the point that if it gets to 0, then it becomes a horizontal line. This is also the same thing for the other side. So if we start from 10 right here, we go all the way to 0, then the graph becomes wider and wider up to the point that it becomes so wide that at 0, it becomes a horizontal line. On the contrary, we remember that the farther the value of A is from 0, meaning if we go towards the negative side, then the graph becomes narrower. So as we go farther from 0, it becomes narrower. We remember that the coordinates h, k is the vertex or the locator point of the graph, where our h translates the graph left or right, while the k translates the graph up or down. Okay, the first step in order that we can sketch the graph of this absolute value equation that we have right here is to determine the vertex or the locator point. So I'm going to go ahead and write that down here. The vertex or locator point has a coordinate of hk. Now, in order that we can determine its value, then we go ahead and the trick is switch the sign of this, so that would be a -3, and keep the sign of this, so that would be a -5. So then our vertex is sitting at -3, -5. The second step is to create and complete the table of values. So I'm going to go ahead and create the table of values down here. This vertex that we got at the beginning will be placed in the middle of these blank boxes here. So I'm going to put in -3 and -5 down here. And we are going to determine the rest of the values of x here. So we can go ahead and write -4 here, and this is -5. So we go the other way, that would be -2 and -1. Our next task is to determine the values of these boxes. So we're going to go ahead and show the work down here. We're going to start by determining the value of y whenever x is -2. So I'm going to go ahead and write x equals -2. So what we would do is we will plug this -2 into the x here. So our equation would come out. That would be y equals, we can change the 1/2 here to its decimal version. That would be a 0.5. And so that is the absolute value of x plus 3. And then that's a -5. And then we again have to put in the -2 to the x. So I will put the -2 down here. So our equation would come out 0.5 absolute value of negative 2 plus 3 is positive 1, and then that's a minus 5. So then that is 0.5. The absolute value of 1 is 1. So I'm going to go ahead and write 1 right there. That is minus 5. So 0.5 times 1 is 0.5, and then that's minus 5. So this gives us a value of negative 4.5. So this one right here is negative 4.5. Now let's determine the value of y whenever the x is negative 4. So it's the other way around here. So I'm going to go ahead and show the work down here. Okay, the value of y whenever our x is negative 4 is negative 4.5. So this is what happens. So I put in the negative 4 to the x. So negative 4 plus 3 is negative 1. The absolute value of negative 1 is positive 1. It's always going to be positive. So that's positive 1 times 0.5 is 0.5. Then we have a minus 5. So then we get a negative 4.5. So what are we going to do next is we are going to show the value for y whenever the x is negative 1 and for the x is negative 5. I'm going to go ahead and show that work down here. Okay, the value for negative 1 is negative 4, and the value of y when x is negative 5 is negative 4. Now, notice this very carefully. The absolute value of 2 is actually positive. That's how I got the positive 2 right here. And so when we multiply 0.5 times 2 is 1, and then minus 5 is negative 4. Now we are ready to move on to the third step. The third step is to sketch the graph. So we're going to sketch the graph down here. So we're going to start with the vertex. Again, you can start anywhere, but we're going to start with the vertex that's negative 3 and negative 5. So that's going to go down here. And then the next dot would be a negative 2 and negative 4.5. So that is 1, 2, 3, 4. 4.5 would be halfway between 4 and 5. And the negative 1 is on negative 4. So it's going to go down here. And the negative 4 is going to go to negative 4.5. So that would be right here. And then negative 5 will go to negative 4. So I'm going to go ahead and sketch the graph. So this is the graph of this equation that we have right here. Now, please notice that this left side of this graph will go infinitely towards the negative x-axis, and this will go infinitely towards the positive x-axis. So then we can go ahead and say that the domain for this would be all real numbers, while the range here would start from negative 5 going up. So I'm going to go ahead and write that information up here. Now, let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to determine the locator point or the vertex. I'm going to go ahead and write that down here. Again, our vertex is the H and K. The trick to determine the coordinate of the vertex is switch. So this comes out negative 2. And then keep this. So that would be a positive 7. So our vertex is at negative 2, 7. The second step is to create and complete the table of values. I'm going to go ahead and create the table of values down here. We are going to place this vertex in the middle of these blank cells. So it's going to go this way right here. So this would be negative 2 and 7. So we can go ahead and say this would be for negative 1 and this is for 0. And then this one right here for negative 3 and negative 4. So we are going to determine the values for each of these 4 boxes that we have right here. So we go ahead and show the work on the side here. We start with determining the value of y when x is negative 1. So that would be x equals negative 1. So I will plug this negative 1 into the x here. So our equation would come out y equals 1/4 is 0.25. So I can go ahead and write negative 0.25. Absolute value of x, that is negative 1 right there, plus 2, and then that's plus 7. So I put in the negative 1 right here in placement for the x. And so this would come out negative 0.25. Negative 1 plus 2 is positive 1, and then that's a plus 7. So this is 0.25. Absolute value of positive 1 is 1, and then that's a plus 7. So this comes out negative 0.25 plus 7. This would be positive 6.75. So I'm going to go ahead and write that down here. So this is 6.75. Now I'm going to show the work for negative 3, or x is negative 3 on the other side right here. Okay, the value that we have here would be 6.75. Now notice this very carefully. Negative 3 plus 2 is negative 1, and then the absolute value of negative 1 is a positive 1. And so we have negative 0.25 times positive 1 would be negative 0.25, and then add that to 7, that would be 7.65. Now we are going to determine the rest of the values here when x is 0 and x is negative 4, and I'm going to show the work at the bottom right here. Okay, so we have completed the table and the work is on the side right here. The third step is to sketch the graph of this table and of this equation. So we're going to start by, again, you can start anywhere, but let's start from the vertex. Negative 2, 7, so that's going to be negative 2 right here. We go up all the way to 7, so this is our vertex. Negative 1 is going to go to 6.75. So that would be 5, 6, 7, 6.75. Should be close to 7, but it doesn't really touch it. And then we have 0 is to 6.5. So that is between 6 and 7. So that should sit somewhere around there. And then we also have negative 3. So 1, 2, 3. That is 6.75. So it's almost at 7. And then we have negative 4 would be at 6.5. So that should be in the middle between this. And so we're going to go ahead and sketch the graph. So this is the graph of this equation right here, and this table represents this graph right there. Now please notice that the left tail of this graph is going to go to the negative infinity on the x, and then this one is going to go to the positive infinity on the right. This tells us that our domain for this graph would be all real numbers, and our range would be the numbers that are below or equal to 7. So I'm going to go ahead and write that information right here. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!